Welcome back to the bench, everyone. I know it's been a little while since my last video. Other things have come up, other expenses. But I have finally gotten the B&K 1076 to a point where I can actually use it. So I want to go over the things that I have done to get it in relative functioning order, and then we'll fire it up and see how it works. To start with, I haven't really done anything to the front panel. I suppose I should clean it with something fairly weak. I've used alcohol on certain things before and it affects some stuff. This being silkscreen, it shouldn't have too much of an effect on it. I just try to be cautious. Some of this is more corrosion and I might use brass wool or something to try to knock it off there, but I don't want to damage any of the markings. The real changes are actually underneath and on top, so we can do a quick look above the set. Okay, starting off overhead here, let me find a stick. The daughter board over here for the horizontal section and deflection circuitry cleaned up, replaced most of the, I replaced all of the film caps that were on the electrolytics. I also replaced the two mica capacitors that this thing has in it. There's one tucked right here between two of the miniature tubes, and there's another out of the way down in here right next to this adjustable mica capacitor. I swapped those out because I was having issues with the horizontal circuit not being stable. Every so often you would hear it twitch, the pitch would change, and the image on the screen actually would flicker a little bit. So there was something off. Maybe one of the caps was starting to arc due to damage to the dielectric layer. Don't really know. I just decided to swap those two out because there was only those two micas in there, just in case. That seems to have gotten rid of it. So happy with that. I did replace a fair number of the resistors on this board. I don't know if I mentioned that last time. I probably did, and I'm just repeating myself. So this board right here is pretty well dealt with. My main focus for the rest of it, of course, was over here on the sync board and the video amplifier section. So this guy up here deals with the audio signal. There's the RCA jack on the side with a volume control and a 4.5 megahertz crystal. This provides the audio output either a fixed tone or it'll modulate the audio signal plugged in, so you can hook an iPhone or something up to it, or record player, or whatever you feel like. There are just two electrolytic caps on there that I replaced. I didn't mess with any of the resistors on that board because being the audio section, it wasn't quite as important to the functionality of the unit. I probably should go over the resistors on the video amp and sync pulse board, quite honestly, but I'm leaving it alone for now because I've got it to a point where I can actually demonstrate it. So I don't want to go in there, mess with a bunch of things, and then have it stop working and have to work backwards. This board does have two electrolytics, this one here and this one here. I had to stretch the leads a little bit to reach. And the second high voltage capacitor in the unit, there is one 0.1 microfarad 1000 volt film cap underneath the chassis, and there is a 0.05 1000 volt cap that goes right here. I happen to have, the 0.05. I had some 0.047 microfarad 1600 volt film caps laying around from when I did the Motorola. So I got one of those in there, and I had to make some extensions using some solid core wire because these were intended for PCB mount. And so the leads were less than a quarter inch long and pretty useless. Now, let's see. The other thing that I had to do to get this thing to work... Oh, well, I should backtrack a little bit. Initially, I was having problems not getting an image. So there is the one high voltage cap on the underside of the chassis, the 0.1. That happens to be part of the horizontal, the feedback, the flyback circuit. And it's connected to the feedback part that goes to the 6DQ6, or 6DQ5, I forget which this is. Anyway, the driver tube The grid for the driver tube has that capacitor attached from the grid to ground. And nearest I can tell, it was probably leaking something fierce, and it was dragging down that signal and preventing the flyback circuit from actually generating the appropriate 11,500 volts the CRT required. At best, I was getting about 7,000 optimistically when it was at full operating voltage. So swapping that out with I daisy-chained a pair of lower voltage capacitors in series to get the right voltage, and tried it out, and sure enough, once I had that cap replaced with a newer one, the voltage came up, I got luminescence on the CRT, and that at least was good. I did not have a video output signal. I tried quite incessantly to get this thing to output something. I could see it produced sync signals. I did have some kind of a signal on the video output, but nothing that would react to interrupting the beam of light to the photomultiplier tube. So obviously there was something going wrong between the screen lighting up and the photomultiplier tube actually picking up those signals. So I focused most of my effort over on the video amplifier board, and I went through and I checked to make sure that the inductors, there are two of them here that are part of the video signal path. This 0.05 capacitor right here is actually where the video signal comes off of the photomultiplier tube. So I was checking the signal output from that with my oscilloscope, and honestly I couldn't seem to get anywhere, and I gave up on it for a few days. And eventually I started looking at the schematic again, and I decided to go back and start testing resistor values, because the photomultiplier tube has a resistor voltage divider underneath it, made up of a number of 22 and I want to say some 33 kilo ohm resistors. And then at one end, the middle of the ladder has grounded. The lower section of the ladder is connected to a negative 150 volt DC supply that's provided by the two selenium rectifiers underneath the set. And the top end is connected to a positive 265 volt DC supply, give or take. Now I went through it and I checked all those resistors, and every single one of them was well within tolerance. I mean, they were almost exactly the listed value on the paperwork, which is pretty unusual for what I think were mostly 10% tolerance parts, not the nicer 5% tolerance gold band guys. I think most of these are, yeah, almost most of these are 10% tolerance. Either way, they were all in spec, so that was odd. What I found, though, was I did have negative 150 volts at the low end of the ladder. I had absolutely nothing at the top end. So I traced it back on the schematic and found that the supply for the 265 comes out at this capacitor right here at this leg. So I double checked to make sure we had anything there, and sure enough we had 265 volts at this capacitor. So working back from that, what I discovered is that there are actually two main chassis configurations or circuit revisions. The first circuit variety that they came up with, the power supply for the upper half of the divider comes directly from this capacitor, goes through the top of the ladder, and then partway through the upper half you have the video control, which is this potentiometer right here. This is tapped in between some of those 22 kilo ohm some odd resistors, and that effectively alters the B plus being applied halfway up the ladder. Now I checked this one against the schematic and it didn't match worth a damn. So I flipped through the manual, and sure enough the page after the schematic, the initial schematic, was a revision, and that one has the video control placed at the very top of the ladder. It is in fact the very first thing the B plus comes through before it gets to the tube. So when this thing is cranked all the way down, you get basically no positive B plus to the photomultiplier tube on the top end of the scale. There's always negative 150 being applied to the bottom. That doesn't seem to be adjustable. So I went back up here, checked the terminals, got 265 at the top of the resistor, nothing at the other end. And I remembered I'd cleaned both the horizontal potentiometer here and the video one with some deoxide a while back, and I thought I'd clean them pretty good, so I took the connections off of this, put my meter on it, and got absolutely nothing. So I took it apart, and I don't know if this will show up at all. This is the inside of the video control 250 kilo ohm potentiometer. Let's see if it's at all obvious. So you see how it's shiny down here at the bottom, at the right and left, and it's fairly dull everywhere else. That right there is the only carbon remaining on this track. That's it. Just those two spots, the two extremes. Everything else in the middle is gone. This potentiometer has absolutely no continuity anymore. It's fried. I can only imagine how much use this thing got, because it doesn't look like it overheated, it just looks like it was obliterated from constantly wiping it back and forth. So I dug through my bin of random potentiometers, and sadly I didn't have anything 250 kilo ohms, plenty of 1 mega ohm and 500 kilo ohm pots for volume controls. I did manage to locate a 400 kilo ohm potentiometer in that pack, and so that is what I have subbed in right now. It's a little long, so it protrudes at the front just a little bit more, but it does at least get B+ where it's supposed to be to the photomultiplier. And once I had that in there, I was actually able to get an image. So that was a huge step forward. Now, it's not perfect. It's okay. I am still using the original 4422 photomultiplier, but I did order a pair of original RCA 931A photomultipliers, which is what this set would have originally come with. But we'll get to trying those out in a bit. I just want to show you the underside of the chassis and a few things I wrapped up there. Okay, I've got the chassis up on its end because I don't really have any way of setting it perfectly flat on its back. It's got a lot of delicate parts, and I don't have anything tall enough to really hold it up. So starting at the bottom here, on the bottom left, we actually, why am I using my finger? At the bottom left, we have the video output jacks with this rather large resistor across it. And this is the original 20 microfarad non-polarized electrolytic that was part of the output circuit. So the video signal actually goes through this cap before it goes to the positive terminal on the video there. The other is just a ground, and this large resistor is simply attached to that. I want to say it's somewhere around 470,000, maybe more. Something like that. The trouble was, when I went through Mauser to look for a replacement, what I found was that in terms of electrolytics that they had that were non-polarized, they didn't have anything anywhere near 20 microfarads with a 350 volt rating. Lower voltage stuff, yeah. Higher voltage stuff, no. Maybe I wasn't looking at exactly the right spots, but I had a hell of a time trying to find an equivalent to this in their normal aluminumized electrolytic category. However, when I did the crystalliner, I used a fairly large 68 microfarad motor start film cap, and it wasn't very expensive, and it did the job just fine. So I went through the film cap section, and sure enough, I found a 22 microfarad 450 volt cap, same manufacturer, same style, and got one of those. Really stumpy leads on it though, so connecting it, I reused some of those leads there, and it's pretty well tied in place. That works really well. No issues with there, and I won't have to worry about it drying out or anything. I have not touched the two selenium rectifiers here on that negative 150 volt power supply. They're fairly small, they're not drawing really any current, so I'm not too worried about these going up in flames. I'm going to leave them alone for now, because I'm not giving this piece of equipment back to anybody. If I was, I would absolutely be replacing those, because it's a failure point. But since I'm using it, I'm not too worried about it, because I'm only going to use it fairly sparingly. Anyway, this is, let's see, one new electrolytic here. I left the original in place because I didn't want to drill out that rivet right now. Same thing with this. It was an inaccessible location. I'm not going to mess with it. I'm just going to leave it there. This chassis did have some modifications made to it. This potentiometer up here is not original. It's a replacement for one, and they moved some of the wiring around, and it doesn't show up too well in the schematics. I had a bit of an issue following where the connections were supposed to go. Still seems to work though, so I'm going to leave it as is. And wait a minute, I just showed you something that was out of screenshot. Of course I did. You might notice there is 1 or 2 film caps still in here that I have not touched. This one, and there's one further above it. I haven't touched them because these are outputs that I would almost never use. I will replace these eventually, but right now, what is this one? This is the sync output. I have no reason to use that, and the other is part of the vertical grid drive connection, which, again, I don't have a use for that function. So let's move north a little bit. And check out what's going on up here. So this is probably the bigger change. This was where the electrolytic multi-section capacitor was. Let me turn this over here real quick. Yeah. It was riveted right there, but I drilled that out and removed the clamp. Used one of the flyback screws to hold this terminal strip in place, and the new 4 electrolytics are actually installed in the exact order they appeared. So the 247s, 40 microfarad, 40 microfarad, 80 microfarad, and then I believe there is a little 50 microfarad at like 50 volts or something along those lines. I also reused all the original wiring with the exception of the grounds. I did have to add a jumper for that. So all of those originals are long enough to reach this just fine. It takes up very little space, and it's honestly very neat. I was very happy with how that came out. Earlier I mentioned there was some modifications and replaced some potentiometer. That would be this guy right here that sticks up to the top of the chassis. This 15,000 ohm, fairly large wattage resistor is also a replacement, but I double checked it against the schematic and it is correct, and it does seem to be in the right place, so I left that alone. The real key though was up here, if I can get it in the frame. That little guy right there, that is the capacitor that's part of the horizontal flyback feedback circuit. And that is going to ground on one end, and the other end is part of this, part of the coil and everything. And then you've got this great big wire heading back to the flyback there. Again, if that drags down the grid connection to the horizontal output tube that drives the transformer, then I imagine the output would probably not swing as high, not produce as much voltage. That's my best guess. It just got leaky, like older caps tend to do. But replacing that gave me an instant change, gave me good fluorescence on the screen. So, very happy with that. And that honestly about does it under here. I didn't touch any of the resistors that are under here, except for I did replace this one just in case it was part of the horizontal circuit and it was a little out of whack. I replaced anything that I thought might cause the issues with the high voltage that I was experiencing at the time, and then I replaced that cap and everything was fine, so not totally necessary. But let's get it flipped back over, get it plugged in, and I've got my portable General Electric television set up to use as a monitor. We'll start with the original 844 or 4422 photomultiplier tube that's currently in the set, and then we'll try out the other two 931As that I just bought to see if they're any better. And the nice thing is, this has a switch on the front that allows it to go into a standby mode. Just position here. So that switch down there, the middle position is standby, so all the filaments will be lit, and then flipping it to the on position will apply B+ to the entire thing. So if you're changing a slide, you can flip it off and not worry about hitting the top of the horizontal or the high voltage output tube and getting hit with 12,000 volts. And it also means that I don't have to worry about the set freaking out when I pull out the photomultiplier and plug in a new one. Because it doesn't have a filament, I don't have to worry about warm-up time or anything. I can just swap it out and go. So let me get the camera repositioned and get that set up. Okay, this is trial run number 1 with the original 4422 photomultiplier tube. Test set is got the video output cranked all the way up, IF attenuation about between 7 and 8, just enough to produce a relatively stable image, and horizontal frequency is stable. We are on channel 2 right now, and let's have a look at what the TV is showing us. There is our test pattern. It's pretty grainy, to be completely honest. I'm not sure whether that's an artifact of the photomultiplier tube or the fact that this set is only aligned using a basic AM signal generator method and not properly stagger tuned. But it works well enough, and it's got a nice stable image, much more stable than my portable airline unit that I tried running the signal to the first time. So that's channel 2, and I can also show that we have audio output. If I can just remember where the volume knob is, it should be the bottom one. Yep. So we have our test tone coming through. Now we're going to switch to channel 3. See, we still get something, but if we snap it over, there it is. So we do get channels 2, 3, 4, 5, 6, 7, 8, 12, and 13. We don't get 9, 10, and 11 for some reason, although this TV has it. The 1076 does not have an output for it. And I suppose we should also check the IF output. So let me see if I can't. Oop. Yeah, okay. So that's interesting. Intermediate frequency somewhere below 30? No, that can't be right. Figured it'd be higher than that. Well, this is locking it right about 30 megahertz, at least according to the tuning scale. I don't know how accurate it is. But there it is. So that's the IF output. Go back to channel 2. And all that seems to work pretty darn well. Now, I want to try swapping out the photomultiplier tube with one of the 931As that I got in the mail. Preparing for test number 2, 931A, original RCA. Pretty sure this is new old stock. The box is still marked for it. And switching on the B+. Well, we'll crank it down for a moment. Switching on the B+ now. And slowly cranking up the brightness. Or that is producing a really, really good image. So this is cranked all the way up. This is an incorrect potentiometer anyway. But the image we're getting, I can see the graduations at least up to 200 now. With the 4422, previously I could only really get 150. So that's really good. A twist on the RF-IF attenuation and see what happens. Okay. Interesting. That's just the horizontal. Okay, so that looks pretty decent. If I adjust the channel fine-tuning, it washes it out a little bit. If I crank it all the way to there, that's about as good as it gets. Let's try channel 3. So we'll move it up 1. We'll move this up 1. Let's see how good. Well, it's interesting. It seems fairly washed out in the whites, and I'm not sure if it's because of the contrast control. See that? That's. What am I twisting? I can't remember the order. Okay, brightness is the second. Third one down is contrast. So outside of making the blacks more black, not too bad. We don't need a ton of brightness. However, I'm not getting very good lines at the top there. And I did clean these, or this slide. I don't have any others, sadly, so that's about as good as it's going to get. So that's pretty good. So I am very happy with the fact that I have at least one really good operating tube. Now the top of it, why is the top of the image, it's just acting weird. Thought I got rid of all the stability issues, but it looks like it's going to be a bit more finicky about that. Is that because I don't have the horizontal frequency right where it wants it? Okay. I was going to try to shift right there. No, it's just being a little squirrely. Either way, so that is 931 tube number 1. That looks pretty darn good. Let's switch off the B plus on the set and try out tube number 2. So we're going to crank the voltage down on the tube, switch off the B plus. This is a handy feature because it prevents me from having to switch the thing off and on again. It's not great on filaments to shut it down and immediately fire it back up. Cycling them really rapidly is not that great. Okay, there's another 931A. It's like a 550 date code. We'll gently pull this one out. Is this one labeled? 117 date code. I wish I knew how to read those. Alright. Number 2, firing at B+. Let's see when we start getting an image with this one. Okay, I'm starting to see something about 6 on the dial, which is a little earlier than the last one. This... I don't know. Okay, so if I have adjusted in just the right area, we can actually discern, or use some other device. So the semicircle, the circles in the center of the image here, are actually different shades. So we have super black at the center, slightly less, and then another ring, and then another ring. I had the video output cranked up all the way, so it was washing these out and making them all pretty black. Looks like the resolution, I could see about 200, nothing past that in terms of the lines. Not really much better up here. I have been told by another enthusiast that has much more knowledge about this equipment than I do that these things really don't have that amazing of an output, and the fact that I'm using it with a non-fully aligned television probably doesn't totally help. But honestly, at the end of the day, the real utility of this unit is just being able to send a signal to the television and being able to check the channels individually and being able to insert a video signal either directly into the video stage or through the intermediate frequency stages with adjustable immediate frequency modulation, which is not something I can accomplish using a VCR or a simple Radio Shack modulator. So there is a use case for this. Half the features are kind of pointless for me. I'm not going to be using the yoke checking functions or the leakage or the shorts checking or the sync or the bias outputs. Maybe the bias output for doing alignment stuff. But a lot of the other features that are more or less superfluous, I'm mostly just going to be using this as an image generator and to make sure that a set is working to some degree. So if you don't know if it's aligned, you can at least feed it a test image on all kinds of different channels, maybe crank around, find what intermediate frequency it's sitting at, and you can check in between stages instead of having to feed all the way from the head end at the antenna inputs or the mixer tube in the very head end of things. You can go all the way to the end, right there in the middle, or at the beginning, which is not something a lot of other... I'm actually not sure if there are any other test equipment for television like this that were actually capable of doing that. Signal-wise, probably, but not with an actual video signal. So this thing is actually pretty useful for that, so if you... I'm certainly going to be using it. And I definitely want to have some more transparencies made. You can get transparency paper. I think it's good for both inkjet and laser printers. I have to see if the Xerox at the office will actually produce those. So you can do just about anything you really want. You know, I guess if you really wanted to, you could do shadow puppets. I'm sure sticking my fingers directly above the B+ fuses is an incredibly safe setup. But yeah, this is just a really, really neat little piece of equipment. So as far as the rebuild goes with this, I'm going to call this more or less repaired and ready for demonstration. I am going to put a replacement 250 kilo-ohm potentiometer on order from Mauser. For right now, this 400 stand-in will work. Hopefully, I'll be able to get one relatively soon, but I gotta get paid, number one. I've got other stuff that's a little more important. I gotta buy some more suspension parts for one of my cars. So, really happy with how the tube situation turned out. It was nice getting a better photomultiplier tube in there, really improved the signal quality. I'm going to take a crack at making a different cable for this, though. I have one extra of these Switchcraft 2501 connectors, and the cable I was using was the one that I built for my Heathkit sweep generator, and the output of that, I want to say, is across a 75 kilo-ohm resistor? I'll have to check the schematic. So it's got a fairly specific load on it that this I don't think had anything special. It was just a pair of alligator clips connected directly to this jack. So since I have this one, I'll go ahead and I'll wrangle up some coax and make a much more simple connection for it, especially since the cable that was used here was also used for connections to the flyback. Now that I think about it, having that exposed Switchcraft center button like that on a high voltage connection is maybe not the best idea. Either way, very happy with how it works. It's going to be a lot of fun to demo this. I'm going to get this back in its cabinet and do a final test to see how it works with it in the cabinet. One thing I did not capture on camera, because I was not paying attention, is that when the overhead LEDs were on, the photomultiplier tube was absolutely engulfed and the image was pretty much wiped out. So I'm going to guess that these LEDs are producing a lot of ultraviolet light and are just swamping the poor thing. I'm not sure if the white light actually really affects it, because it's supposed to be sensitive predominantly to the ultraviolet spectrum, and I don't know what range of light these LEDs are actually outputting. But good chance that it's in the range of that. I suppose I could try like a small LED flashlight, or like my phone, put it back in the cabinet, fire everything up, and see how it's affected. So yeah, actually we'll do that. Let me package this thing back up. We'll set it back up with the television, and then I'll see how it reacts to various light sources. Okay, the unit is back in its cabinet. I need to replace the rubber feet on it, though. They're pretty crumbly. We've got the output hooked up over to the General Electric television just off screen there. and I've got the B plus on standby. So what I'm going to do, so set the output on that to channel 2, and then we'll, let's see. What I want to do is test how the photomultiplier tube behaves inside of an enclosed box, and then with the lid open and exposed to a light source. So for starters, I'm going to seal the unit up, move you around to the television, and fire it up and see what we get. So let's go and see what we get on screen. To make things a little easier to see, I'm going to turn off the other light here, and there's our pattern. It's actually pretty good looking, honestly. Curious. If I lift the lid, okay, we do have, that's interesting. I wonder if the metal chassis is actually interacting with the deflection circuitry. Huh. Either way, that seems to be working pretty good. Now, I do have the audio set to tone, so we should be able to hear it if I turn this up. Yep. So that's honestly not bad. Let me adjust the video. Let's see. Because if we crank the video all the way up, ooh, that gets pretty bad. However, what we want to try and do is get, the target, so that we can see the individual rings. 1, 2, 3, 4. The center's still a little too black. If I back it up a little bit, and that might also be because of the contrast. Where have I got the RFI attenuation? Yeah, it's a little sticky. But that looks pretty good, quite honestly. The image, it still isn't super linear, I don't think. To me, it seems a little squished. Not sure. I don't think I can access the vertical linearity on the back of that set very easily. So we're not going to mess with it. So we do see that opening the lid does have an effect on the picture tube. Now, if I turn on the overhead lights with the enclosure sealed up, what happens? Nothing much, just makes it a little harder to see on the screen. However, if I then open the lid with the light overhead on, it pretty well blurs out the image there. So we'll go ahead and seal that back off. Now what I want to see though is I have a pen light, and it is LED. I want to test and see if incandescent has any effect versus LED. So if I shine an LED light in through the side of the grates, that throws it off a little bit. How about through the top? Not really. How about directly at the photomultiplier tube? Yep, completely blocks it out. Now, somewhere around here I have a mag light, and I want to see what that does. Well, I'm sorry to say, I do not know what happened to my mag light, so I will not be able to test an incandescent light bulb on the photomultiplier tube. But suffice to say, a decent light source that outputs in the ultraviolet spectrum will probably block it out. I don't know if the other parts of the spectrum have any effect on it, but it is entirely possible they do. But I can see why they put this thing in an enclosure. It is odd, though, that there is no shielding around the photomultiplier tube itself. Examples I've seen online showed shadow masks that covered all but the actual sensitive surface. There's a specific part of the tube that light will actually enter and strike. The rest of the glass enclosure is really unnecessary. So usually there's a cardboard sleeve over it, and in some cases they actually specify, or RCA specified, the use of a focusing lens assembly to get the light aimed better at the photomultiplier tube. In this unit, they just placed it 6 inches away from the screen and called it good. And the fact that it works, I mean, is a testament to the technology and the design, I guess. It's pretty simple, honestly. So, I am very happy with how that went. Now there is one other function I do want to try, and that is the external audio input. I've got it set for tone right now, but let me grab my phone and we'll switch it over to the external input. First we need to find some music that won't get me flagged. The RCA jack is adapted to a 3.5mm, which is in turn plugged into my iPhone here. Set this to audio. That cause it to change a little bit. And let's try. I think I hear something. Huh.
Man I love, and when he comes my way, I'll do my best to make him stay.
I don't know about you, but the sound quality on that is surprisingly good. Let me check the fine tuning on channel 2.
I know we both
Now the volume control on the back of this unit, so that looks like full on. Okay, so that's with, I'll turn this down. That was with my phone at maximum output and the unit here at maximum input volume control on that little neural potentiometer on the back. So yeah, this does seem to have a very good FM modulator in there for the audio signal, so that's pretty cool. Might as well just roll through the other channels just for the heck of it. So if we flip over to channel 3, there it is, 4. Now, I'm not adjusting the fine tuning at all right now until I absolutely need to. Six, which is apparently close enough that it doesn't need much. 7, no, still pretty close. 8. And this does not have 9, 10, or 11, so we got to skip all the way to 12. And there goes our signal. Scoot. There's 12. And finally, channel 13. And there we go. We've got a stable video signal on every channel. It looks like I will have to touch the fine tuning a little bit to get that slight regularity at the top there to go away. It does also have a setting to go through the IF transformer, so if we crank it all the way down to IF, and then I move this around, we should find, and I did this before, huh. That's interesting. Last time I did this, it didn't have an issue finding the intermediate frequency and working correctly. I don't know why it's not wanting to do that now. Maybe because I'm so far up on the channel scale. Let me move this back. Okay, so that's around channel... Okay, so that's channel 3 we're currently on. If I go to intermediate frequency, yeah. Starts to lock in somewhere between 30 and 35 megahertz. I don't remember what the spec is on this particular set. Yep. But let's see, if I switch on the color, don't have a color set to try it on, so And video clarity. Doesn't really do much. But I think that about wraps it up for this unit. So, all in all, this is... Oh, shoot. One thing I don't remember if I showed was the actual luminescence of the CRT. I apologize. Take a look and see what it actually looks like when everything is all bright inside here. It's a little tricky with this thing being on a stick. So there's the horizontal section, but if we bring it... Yeah, crying out loud. So that's what the CRT looks like when it's illuminated. And it's just staring down the 931A at the other end there. And then most of the light is trapped over here. I'm surprised this bulb isn't shielded in any fashion. But really, it's a very, very clean little setup. And I honestly couldn't be happier with it. So, thanks for watching. I do anticipate using this in future videos. I've got a bunch of other televisions that need to be worked on, and this will definitely come in handy. But I feel the itch to actually start working on some of the radios that I have in my hoard that need attention. I've got one that's been sitting on the shelf and it stares at me every time I come in here, so I think I will drag that down probably sometime next week and we'll start working on it. In the meantime, thanks for watching.